Okay, let's subtract two vectors. This time again I have my a and my b, but this time I want to subtract a minus b. So I come over here, find my chalk. Here's a, and this guy is b. And if I write the expression a minus b, I can rewrite that as a plus the negative of b. Notice that I put an arrow on top of these things because these are vector quantities, and I want to make sure that when I add or subtract them, I don't just write down the magnitude and add or subtract that. That's almost guaranteed to give me the wrong answer. So what I need to do is add a and negative b, and I've already figured out how to do the addition graphically. So let me take this vector here, and to get negative b, all I have to do is flip it around the other direction. And unfortunately it's a little too long, but what I have is negative b down here. And if I want to add these two guys together, think of it again as an orienteering problem. I start here, I go east a certain amount, then I go south a certain amount. Whoops, I better move this guy over to have its tail at the tip of A. So now this is still negative b. And if I zoom out, I want to start at the tail of A and go to the tip of B. So my solution here is going to be this. This is A minus B, which is equal to A plus negative b. Always put those arrows on top just to make sure that you're communicating that it's a vector problem. And here it is again. We had a and b. The first thing was to flip b. The second was to move it over here to have its tail at the tip of a. And then from the tail of a to the tip of b, that's our subtraction. Now, you may notice I could have done it this way. All right, the difference between B and A is this arrow right here, which just goes from the tip of one to the tip of the other. The problem with doing this is that it's almost like flipping a coin here in terms of getting the right direction. So the preferred method of doing this is this guy right over here.